Let's work on our first Go block. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. If you recall, when I was coding our first block entities, I showed you that we have to add a tick method and then we have to add a block entity. And at that time, I wrote my Go base. However, after that video, I started developing my own library system and now I'm using my abstract block from my library system and things are changed. So if you notice, instead of having my own Boolean property called activated, I now have this properties.powered property, has powered property. Now, my abstract block is accepting a block properties. This is my own class, Jiraiya GBase properties. In that properties, I have this has powered properties, has horizontal facing, and then we have has enabled, has locked. Here we go, has powered properties that is assigned the true. And as you see, it says add powered. If I go into add powered, you see that all I'm doing is adding the properties.powered with a default value of false to our state. So this single line is equivalent of adding an enum property on top, setting the default on this constructor, and then appending the properties. It all happens in here. Of course, I tried to cover all the Boolean ones from vanilla, so powered, enabled, locked, and unstable. Now that I think about it, maybe I want to switch from powered to unstable. If I find it, powered, lit, locked, enabled. Oh, I didn't add the unstable. Okay. Yeah, I didn't add the unstable. Okay, I will add it in between the episodes. But right now I'm using powered. That's okay. It doesn't matter because you really don't see it in the game. Okay. In this particular case, we are not changing the model based on the property. And because of that, normally you wouldn't see that property and its results in the game. You just use this property internally for the functionality. So let's use that powered for time being. Now, here's the thing. Because I'm assigning false in my library as the default value, we don't need to set that default value here. If I want to add the default value, I have an overload that I can send in true as the overload, and this will become the default value and it will be set at the state. So I don't have to set the state in the constructor anymore. However, it means that the onPlace and onUse with item now needs to be written. onUse on the G block, as you see, is setting some properties and then calls onUse. Let's see what it's doing. It says that if you have a GUI, keep in mind, if you have a GUI, please open handle screen for that GUI and return action results success, otherwise called a super. Here's the thing. I could leave it as it is because it doesn't matter right now. We are not multi-block and I don't have the code for multi-block and the block does not provide any user interface. That's okay. However, now that I know I don't need to do anything on the onUse, so why bother? Just return action results success. Override that behavior. Now on placed, when we place the block, we want to make sure that we are still on the false for the powered. How can we do it? We check if the state properties on our property has the powered property. This is my own library usage. Normally, you don't use it this way. Normally in vanilla, if you remember on the block properties, I showed you that you say word.set block state position, get the block state dot with the powered comma false. Basically here we are doing the same thing. You see that we are getting the state with powered comma false. Then we set the block state with this one. However, before this, I need to check if we have the powered on the block that we should. This is a sanity check. If we have it, then please set it to false and notify all, then call the super. However, when we are using an item on it, we had this code before, so we use the copper, rod copper. If we don't have the rod copper as the item that we are using, just go back. We don't have anything else to do. Then this is a repetitive code compared to this. However, take note that we are cycling the powered. It means that we are changing the powered from false to true, and then if we use it again, we cycle from true to false. Now, this is not the desired effect that I want. I will change it with, and I dedicatedly say that it's true. The difference is that our Go block may have a chance, in some special cases, to replace itself with something else. If we are fast enough, maybe if we are fast enough to right-click on the block 2 times, each time, each tick, one after another, we will cycle through between true and false so fast that the block will do nothing. And this is not what I want. I just want the Go block to turn into powered mode and stay in the powered mode until the rest of its life. And that's it. So we say that, hey, turn the power to true and then set the block state on that position with this one and modify all. And then, of course, increment the state of using an item, play a sound, and then if not, is creative, decrement the item stack, and that's it. Okay? Sound categories that block, item, flint, and the steel. Let me see that whatever I have here. Ambience, of course not. Block, no. Do I have like anything like item, amethyst or something? Or anything else? No. You're kidding me. Item, there we go. Armor, not armors. Axe, book, bottle, brush, bucket, bundles, crop, crossbow, die, elytra, fire charge, flint and steel. Oh, okay, we have a really small number of sounds. Of course, we can create our own sound, add it to game. We will take a look at that later. But right now, flint and steel, let's go with fire charge. Okay, so that's that, and there is nothing else going on in the Go base. Now let's talk about the block itself. First things first, we are using the Go base. So we have this Go base, and the Go base is actually using G block, and inside G block we have this codec. Here's one thing that I need to explain, and as you see, I have the to-do for the library at the same time, so I will pass through it very fast right now. Every block inside Minecraft from 1.21.5 need to have a codec, regardless of it being using a block entity or not. Previous than this, we had to add it only for the blocks that had block entities, but now every block needs a codec. Okay, so behind the scenes, we have this codec. We just simply call the create codec ergobump new. Okay, we understand that. However, again, the ergobump being from Go base and Go base from being G block, as you see, we are using that block properties. Remember, on the Go base, we are getting the properties and we are assigning the power to it. So here we don't need to assign the power, but take a look. I say that, hey, I have a block entity properties of this block entity type, and it should tick. Believe it or not, we don't need to override the create block entity ourselves anymore, because at some point, somewhere in the G block, we have two different methods that handles that. Create block entity looks into the properties. If we have that block entity property, get the type supplier. The type supplier is this, mod block entities dot ergobump. Take note, before this, we had to use the same thing, mod block entities dot ergobump dot instantiate. Now, we are doing it here. So remember, that was the type supplier. Okay. So when we call the create on our own library, basically we are calling that instantiate. Here you see that when I say the should tick, it's basically using this IBETick factory that is creating the ticker for me. And here we go. You see, when I say the constructor, we are saying that block entity factory is equals to the supplier, get it, and instantiate. And as I said, the supplier is our key of the type we have in mod block entities. And that's it. So behind the scenes, just by adding these two lines, first, we want a block entity properties with block properties BE, means block properties related to block entity. We are supplying our type, and after this, when we finish the parenthesis, we say, hey, these properties flag the should tick to true. So we don't need to instantiate our block entities anymore in any of our blocks. See how easy and fantastic it became? I could then get rid of this because, well, each block is instantiating its own type of block entity, but this is all the code that now we will have to use to generate a block related to a block entity that should tick. We assign a new properties, we assign a new block entity properties. Inside it, we are sending it the type of the block entity and if we should tick or not, and that's it. Take note, we have a block entity properties and we have this block properties BE. If you look at our block entity, we have this properties that is the type of BE properties. This is the properties dedicated for the block entity class itself. But the block properties BE, instead of BE being at the start, is the properties that are sitting inside the block to handle its relation send to a block entity. Okay, that's the explanation of the library there. Now let's dive into this. We are extending from Tickable BE. Tickable BE is again my own class inside my own library that extends Updatable BE. Updatable BE at the end of the line is a block entity that implements iUpdatable interface. It means that it will have update method. Now this only causes the syncing between the client and server. It's not ticking, it's just syncing between the client and server. On top of that, I have the tick method here, and this tick method has two different things. When we are the very first tick inside the game start, we call the onInternal first tick, and then after that we will call onInternal tick on intervals related to the tick rate that we can assign to a block entity. If the tick rate is 0, it means every tick. So tick client should be empty, and then other things you don't need to bother yourself with it right now. It boils down to that, hey, we have a block entity that will sync itself between client and server without you needing to do anything, and then it's ticking 20 times a second. However, this properties is the type of BE properties. BE properties, as you see, has an instance of iTickLogic called TickLogic, and iTickLogic has two methods, tick and tick client. Of course, I can say default, and I can type it right now, but if I go into the library itself on top, I can say default void tick client curly braces, and that will free me from having this stupidness in all of my block entities. I will do it between the videos, but this thing is actually being used here. As you see on TickLogic, we say, hey, this is the tick, and then we are going to the Tickable BE onInternal tick, you see that I'm checking it. If this tick logic inside BE properties is not null, please call the tick method on itself and send our own properties inside of it. Okay, means that now I can have a separate dedicated class for the tick logic of any block entity. As you see, it accepts a property, and inside this property, one of the things that is being shared is the block entity itself. So I can have the block entity and access to everything on that block entity. The nice thing about it is that it's aware of the type of the block entity, so you don't need to do any typecast there. Finally, this will happen automatically 20 times a second. When I have this tick logic ready as a class in the constructor of the block entity, I say this.properties.tick logic, assign a new instance of this internal class. Now this can be an external class, but honestly I think it's better to keep it an internal for time being until we go into the same tick logic that is based on the behavior trees. That's a totally different story there. However, if the tick is only simple logic that we are after, this is all we need to do. Now we need to write our code here. We don't care about assigning this tick. We don't care about anything else. Everything is being handled by the library system that I showed you. By the way, the library will use GBase and then GiraLib, and that's it. Because if you take note, we are using GBase and GiraLib from my libraries and nothing else. Okay, let's start with the simplest GUI, and that is air GUI bomb. The job of this GUI is that when it's activated, it will destroy itself, and instead of itself, it will leave empty air. Now, why do you need something like this? You will see in future episodes when I'm working on the next GUIs. When we are ticking here, we don't need to check if we are client side or not. If properties.world equals to null, now take note, this will return a warning for us saying that, hey, auto-closable. Now, auto-closable is something that you will never ever see inside Minecraft. So I will say that, hey, disable this inspection. Totally, I don't care about it. If it's null, or if properties.world instance of server world, and we call it SW, but we will negate this second case. So basically we are saying that, hey, if we are null or we are not instance of the server world. Now, keep in mind, when we say if not client, you will think that, okay, it's server. Yes, it's server, but we want to typecast that server to SW to have it, okay? So we return. We don't have anything else to do. If we are basically null or we can't typecast to the server world, return. Take note, I didn't check if world.is client because this, by default, in our library, will happen only and only server side. Then we say state equals to properties.blockentity.getState for the world and the position. Now, where do I have it? I don't have it. So I can say that the world equals to the block entity dot world, and I will use the method call or, okay, this. Then I will say that block pause equals to the block entity dot pause, and that's it. We call it pause. Now, here's the thing. As I said, if we want to be careful about the whole thing, we can make sure that we are caching these into some variable. But honestly, these two are nanoseconds, so I can ignore them. And I will say the get state returns the block state. So I will say block state equals to the state for the world at the position that we cast. Now that we have the state, we want to say if not server world dot get game rules dot get boolean from our rules dot spread. Means that if we shouldn't spread. This is how you can read the game rule in the code, by the way. And you say or not state does not equal to null, means that we are null. But here we say and state dot get air goo bomb dot oh. We need to read the power here. Now instead of that, we can say properties from net Minecraft state properties powered, and this is the closing return. So basically what I did is check that, hey, if we are setting the game rule to false or if we are not powered. So we want to make sure that the state is not null and we want to make sure that we are powered. If any of them fail, return. That's the logic there. After this sanity check, we say float chance equals to math helper from base. This is a library that I have. Get chance. Now for the value, we say we have the configs. Config, was this config or configs in the main configs? So configs, and please import static for main.configs. And here we have dot air bomb goo chance. So we got a chance value. And if you don't know what it's doing, it's basically producing a float between 0 and 1 based on our number, and check if the number is properly in the chance that we want. Normally we set it at 5, so it's 5% chance per tick, means that in 10 ticks it will become 50, and in 1 second we will have almost 100 chance. It's not the perfect math there, but it's close. So each second it should happen, sometimes less than a second, but the maximum normally would be a second. There is a rare chance that it will have for maybe 2 seconds or more. But then we have if world dot get random dot next float is less than the chance that we have. So if we are in the proper, oh, okay, this is stupid, but okay. So we want to make sure that we are less than 5% chance. If that's the case, return. Basically here, we are not asking for 5%. Let me show this get chance for you. It says 100 minus value. So if I send 5, it will become 95. Divided by this, it becomes 0.95. And here we say if we are smaller than 0.95, return. So basically, I only give myself 5% chance. Okay. So we say if world dot get block state at the position dot up dot is of, one parenthesis out, dot is of blocks.water. Now, what is your problem? Why are you yelling at me? Get block entity. No, why block entity? Block state. There we go. If get block state, and it's totally asking about this, so I hope that I can rectify it with this, remove this, and that will solve that. What is the problem now? Null pointer exception. Oh, yes, of course. It should say null. Okay. So actually, if word is null, here I will say return. Basically, I did check it there. So let's do it this way. I will get the word on top and do this. Word equals null here, and that's much better. And again, here instead of this, I can say word. What is the problem now? Okay, it's covered by that, so I will remove that. It should work like charm. If we are water, basically on top of us, we have a water, or word dot get block state on the pause dot up dot is of blocks dot lava. Okay, if one of these two cases, so above us is lava or water, we say word dot set block state for the pause dot up to be the blocks dot stone dot get default state, comma block dot notify all. So if we had water or lava above ourselves, we will switch it back to stone because I want to prevent any falling water or falling lava. Then we say word dot set block state on the position with the blocks.air dot get default state and block dot notify all. Let me copy it, let me paste it, and comment this guy. Now here there's a magic thing that I want to do, I will say torch. Guess what will happen? Let's run the game and see the result, and you will be surprised how easy it is to put a torch somewhere. Of course, right now I make sure that underneath myself, at least, I have a solid block. If that was not the case, the torch would be put in the world and then it would drop as an item on the ground. Okay, let's go into the world. So let's put down a block and right click it with a copper rod. Boom, you see the torch is there, but it didn't happen as fast as I click. It takes its sweet time because the chance is actually working in place and it's not 100% chance per block. So let me do it this way. You see, some of them are faster, some of them are slower. But the thing is that now I have a block that I put in the world, that I right click it with the copper rod, and at any time, by any chance, it will convert back to the torch. Now, normally I want it to be air. So if I just remove that torch block and put it back as the air, the moment it's converting its state, it will vanish and the air will be there without any hitbox and just a normal air block in the game. This is one of the most useful goos that I will have, because sometime in future in some other goo blocks you will see that I will spawn lots of air goo bombs automatically in the world and they will vanish as the time passes. If you like these videos, please subscribe to the channel, hit the like button and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.